Engineering. I'm Alan. In today's video I'll be laying some new flooring in the workshop and we'll have a look at that, and also I'll start to make a lock for the spindle on the rotary head. This lock is made out of plate aluminium. I chose aluminium because I want this to wear rather than the spindle on the head, and it'll lock by clamping together with a screw through here to grip the spindle. This part is clearance. So let's go into the workshop and see how we make it. Today I've spent some time putting down some new flooring in the workshop. This is a rubberized floor and it comes in tiles of 900 by 900 millimeter, and that's divided into 9 tiles. If I turn it over so you can see the back, you can see it has holes in the back and it gives it a cushioned effect, and along the edges are little dimples and raised portions which interlock with the sheet next to it. I have cut these sheets and you can still get them to interlock, and I think they're ideal for the workshop. Being a hard rubber, swarf and bits won't embed into the rubber, so when you come to clean the rubber, all you need to do is sweep it with a soft broom and all the swarf will come off. I purchased this flooring from Home Base. In this video I'm starting to make a locking mechanism for the rotary head so I can lock the spindle when I want to mill a component. And what I've done here is this is just a piece of 10mm aluminium plate. I've marked out 2 components that I want to make, and the first job would be to cut these out on the bandsaw and then mill the side square so I have a reference point. The first thing I need to do is get some edges square. This edge is where the manufacturer had cut it off. This edge is on the bandsaw where I've just cut it. So what I will do is locate off the manufacturer's edge, machine that square, turn it over, just clean this up. So I've got 2 plate faces here that the manufacturer's machined, and these 2 that are done on the bandsaw. finished milling this slot, which is a 5mm slot for the pivot point. I've taken the part out the vise because my vise wouldn't open far enough to put this sideways, and I didn't want to risk cutting into the jaws of the vise, so I've used the 5mm dowel on the other side of the hole. I've lined this up with the head, so all I need to do now is drill this out as big as I can and then bore it to 1.5 inches. I'll try using this hole saw instead of drilling up from smaller to bigger holes. Never used it before, so I don't know whether it'll work. It says it can drill soft metals, and I think aluminium's a soft metal, so we'll see. I'll fit the boring head so I can bore it to the final size. Millimeters to come out. Try again. 50.05, so that will do for that. That's that part done. I've got exactly the same thing to do on another hole. This is what we've got so far. I've machined this piece with the slot. That piece there, that goes into there, so that gives me the centre of the circle. What I need to do now is machine this out with the boring head. Just machining an undercut here, so this misses the bearing. It's 2mm deep and about 65mm diameter. I'm just going to take about 4mm off this side. Okay, this is where we've got to so far. Stepped on the back, and the reason for the step on the back of that is that the bearing just juts out a bit on there, so this will go round, miss the bearing. This part's supposed to be clear because I want the, once I slacken the clamp off, I want the clamp to be free and not still drag. That's the pivot point there. So that will go on there. I have to make pivot for this to hold it there, drill a hole in here so I can screw it down to there, and then a hole through there so that this can clamp up and grip on the end of the shaft. And this is just below the face that the chuck locks up onto. .05. That says just under 12. .10mm diameter, and that's 4mm deep. So the next thing I need to do is drill a hole in the end, 5mm hole, and counterbore it for a cap head. Now I've just touched the end and I'm moving in 12mm because that's the length of the part I want, and then I'll add 2mm for the width of the parting off tool. Just over 10. Now I'm going to use an end mill to put a flat bottomed hole in so that a cap head will fit in. So what we do is when we have this screwed into the headstock, the cap head's flush. The two diameters, the first one will go into the part, and the second one, this face will pull the part down and that will sink in. Okay, let's have a recap. So far, this is how far I've got. This is the 12mm bush that I made. That goes into the 12mm hole, and then a cap head will go through to secure that to the top of the rotary axis. All I've done recently is mill two parallel, instead of this being a circle, I've just milled it parallel each side. So when that's closed, it will grip on this part of the circumference. This part is clearance because I don't want the spindle dragging on this, so this is just clearance. So on the lathe we've just made two bushes with holes in. This bush with a hole in, it's 12mm, and that pin that's 10mm to go there. These are step bushes. The idea of the step bush is when I drill a hole in here, I'll step the hole so that as that goes in, as the cap head pulls it down, the face on the shoulder there will pull the plate down and lock it up. Well, that's it for this week. I hope that was enjoyable, and we'll continue this next week when we fit it to the rotary head and see whether it works. Thanks for watching.